artificial neural networks, right? The three-layered network. So these are also known as shallow architectures, and they are typically called shallow because the number of see what exactly is the depth of this network. So the depth is nothing but the number of nonlinear transformations that can be handled by this network. So in the case of these, what we saw, right, the simpler ANNs, there are only three layers, so they could handle three different nonlinear transformations possibly. But in a lot of cases and real life applications and things like that, where see the function we are trying to learn or approximate, right, is highly varying, which means that there are a lot of point of inflections, and the derivative changes direction very often, and so it's like a very fluctuating function. So in all of these cases, a simple ANN will not be able to learn enough. So basically what it means is, for every inflection point, right, you will need a training sample for it to learn that. And so essentially what will happen is, if it is a highly varying function, the number of training examples that will be required by a very simple three-layer architecture will be too high, and it will become computationally either computationally intractable, or you will not have enough training samples practically. So these were the limitations, and essentially this is the reason people started looking at networks which have lot of hidden layers. So so you saw output layer and input layer, right? Two layers. Then the middle one was what was known as the hidden layer. Now